Hello and welcome to Honors Function. In this video and the next two videos, we will review the properties of linear equations in two variables. Let's start by recalling what is a linear equation in two variables. So this is a linear equation in two variables. Why do we call it a linear equation? Because each variable, x and y, has a degree of 1, okay? A, B, and C are called the coefficient of the equation or the parameter on the equation, okay? A solution of such an equation is an ordered pair U, V, such that if you replace x by u and y by v, this equation, AU plus BV equals C, this has to be a true equation. And that's why a solution is often called a point for obvious reason, okay? What do we call the graph of a linear equation? The graph of a linear equation is the set of all the solution. The set of all the solution is called the graph, okay? That's it, that's all. All right, so how do you find solution of a linear equation? Let's start with a first example. Here is our first linear equation, 3x minus 5y equals -4. Something I didn't tell you before is that the coefficient of the linear equation should be integer, okay? If they're not integer, it's easy to make them integer if they're rational number. If they're real, well, that can happen again, but most of the time they will be integers, okay? All right, so let's try to find some solution of this linear equation. How do we go about it? Well, what is 3x? It's a multiple of 3. What is 5y? It's a multiple of 5. So basically, you want to find a multiple of 3 and a multiple of 5 that are 4 units apart. So let me show you what I mean. Let me write the multiple of 3. So you get 0, 3, 6, 9, 12, 15, 18, 21. Okay, I'll stop here. Let me write the multiple of 5 now. 0, 5, 10, 15, 20, 25, and I'll stop here. Okay, so I want my multiples of 3 and my multiples of 5 to be 4 units apart. Well, check it out. How about 9 and 5? They are 4 units apart. How about 6 and 10? 4 units apart. How about 21 and 25? 4 units apart. And actually, if you look at the next one after 21, it would be 24 right here. And you would also have 24 and 20. And they are 4 units apart. Okay, well, let's make points out of that. So now let me look at the equation. It's 3x minus 5y. So let me look at the first one, 6 and 10, okay? Multiple of 3, 6, multiple of 5, 10. And this has to be equal to -4, right? How do you make a -4 with a 6 and a 10? Well, 6 minus 10. Therefore, what is x? 3x has to be 6, so that's 3 times 2 minus 5 times 2, okay? And I have my points now. The point is 2, 2. Here we go. First point, 2, 2. Okay? I'm going slowly here, but of course you can go much, much faster. So here's 1 point. The second one, I'm going to play with 9 and 5. So the multiple of 3 is first, right? Multiple of 3 first. And then the multiple of 5. How can you make a -4 with a 9 and a 5? You need a -9 plus 5 equals -4. So now let's fill in the x and the y. -9 is 3 times what? It's 3 times -3, right? And how do you get a plus 5 from -5y? Well, it is minus 5 times -1. And here is how you can find your second point. It is -3 and -1. That's it, okay? So you may have done this kind of work before, or maybe not. Let's go for 2 more. So I have 21 and 25. So 21 minus 25 equals -4. So 21 is 3 times 7, that's my x, minus 5 times 5, and that's my y. So my point is 7, negative 5. Oh, sorry, 7 plus 5, right? Okay, let's find the last point. I'm going to use 24 and 20. So 24 and 20, so I need a negative 24 plus 20, and that's minus 4. So negative 24 is 3 times negative 8, and 20 is minus 5 times negative 4, and this is going to be negative 4, and so the point is negative 8, negative 4. Okay? So this is a method that allows you to find very nice points with integer coordinate. Now guys, you have to believe me that many of the equation, many in standard form will give you some integer coordinate if you look carefully. This is a multiple of 2 and this is a multiple of 3, and you want them to be 9 units apart. It's not difficult to find many examples like that. All right? Okay, let's keep on going. So here is a result that I am not going to prove, a result about the graph of such an equation or the set of all the solution. So we saw right here that you had a lot of different solutions to this equation. Okay, many solutions to an equation, actually an infinite number of solutions to a linear equation. All right, so if you were to look at all the solutions, if you were to plot them in the plane, you will find out that all the solution would describe a line. Okay, they would all be on a line, and this is a result. The graph of this equation is a line, and on the other hand, a line defines an equation like that. So there is a one-to-one relation between a line, which is a geometrical concept, and an equation. And this is a tremendous advantage of analytical geometry. In pure geometry, a line is just a line, and there is nothing about it. Okay, a line in pure geometry is just AB, and that's all you can say about it. But in analytical geometry, you can associate an equation to a line. Okay? I'm not going to prove that. It's something that may have been done before, but it's a simple result, but we need to move on. So we just saw that the solution of an equation like that are all on a line, and the line will define an equation like that. Okay? Now, a line is made of points. We defined in the previous section the slope between 2 points. So I'm going to have a definition here that will need to be explained later. And I'm going to say that the slope of a line, we're going to call that M, the slope of a line is the slope between any 2 points, this one and this one, or this one and this one, or this one and this one, okay? The slope between any 2 pairs of points. So this is a big result, and we're going to have to prove that actually it doesn't matter which pair of points you take, the slope is the same. Let's just first notice that on a concrete example, and then we'll prove it. It's very simple. Again, you will see it's not difficult to prove at all. So in this question, we have to find the slope of the line that we worked on in example number 1. So let me remind you of the 4 points that we had find. We had the points 2, 2, negative 3, negative 1, 7, 5, and negative 8, negative 4. Okay? Now, according to our previous definition, the slope of the line would be the slope between any 2 points on the line. For example, let me take these 2 points right here. What's the slope between these 2 points? So 5 minus negative 1, that's 5 plus 1, over 7 minus negative 3, 7 plus 3. So that's 6 over 10. So let's divide by 2, it is 3/5. The slope of this between these 2 points is 3/5. Let's just take another pair of points and make sure our definition does not does make sense on this very concrete example here. What's the slope between these 2 points right here? So we have negative 4 minus 2, negative 4 minus 2, divided by negative 8 minus 2, right? So negative 4 minus 2 is negative 6, negative 8 minus 2 is negative 10, negative 6 over negative 10 is, again, 3/5. So the definition makes sense in this example, and we'll prove that it makes sense in general. Let's do it right now. So I'm doing this proof because actually I'm gonna land on a result that is a bit more general. You will see. What am I doing here? Here's an equation of a line ax plus by equals c given in standard form. Suppose I'm graphing the line, and suppose I'm taking 2 points on the line, 2 ordered pair solution of this equation right here. How would I find the slope? It's telling me the slope of the line. It's telling me to take the slope between any 2 points right here, right? Any 2 points, and you will understand why that works. So let's get the slope between these 2 points. So we have y2 minus y1 over x2 minus x1. Well, what do you see here? Well, nothing, not much, okay? I have to express the fact that these points are on a line. So let me express that. I have ax1 plus by1, that is equal to c. I also have ax2 plus by2, that is equal to c. Now let me try to look at this ratio through this lens right here, okay, by considering these 2 equations. Let me just subtract. I'm going to call that equation 1, and I'm going to call that equation 2. And let me subtract side by side. Let's say 2 minus 1. It doesn't matter the order, right? So 2 minus 1. So we have ax2 plus by2 minus ax1 plus by1 equals to c minus c. So what do we have? We have ax2 plus by2 minus ax1 minus by1 equals 0. All right. Here's what I'm going to do now. I'm going to move my by2 and by1 on the other side of the equation, and I'm going to factor at the same time. I'm going to factor my a's and I'm going to factor my b's at the same time, okay? So I'm going to do 2 steps in one. Look at it. So I have a times x2 minus x1 equals, so that would be a b times y1, right, plus by1 minus by2, so minus y2. Okay, good. And now I'm going to divide both sides of the equation by what? By b times x2 minus x1. b times x2 minus x1. So check out what we have here. So what do we have after cancelling? On the right side we have y1 minus y2 over x2 minus x1. On the left side we have a over b. Now be careful here. This is not the slope, right? You need to start with the same points on both sides. So how about we multiply by -1 the 2 sides of this equation? Let's multiply by -1 this side and by -1 this side. What do we have on the left side? We have, I'm going to give the -1 to the top, y2 minus y1 over x2 minus x1 equals -a over b. Check it out. We have found a result more general than the one we wanted, because what's written right here is that the slope between the 2 points is not a function of the point. It's equal to -a over b. -a over b, let me remind you of the equation. The equation is ax plus by equals c. Okay, a and b are just the coefficient of the equation. The slope between these 2 points is just equal to -a over b. So if you were to take 2 other points like x3, y3 and x4, y4, well, you would find that the slope is y4 minus y3 over x4 minus x3, and you would find that it's -a over b again, right? It's not a function of the point, and therefore the slope between any 2 points would be the same. All right, so this is a result actually that you may want to remember. The slope of a line given in standard form is -a over b. A is a coefficient of x, b is a coefficient of y. Let's go over another example here. So in this example 5, I'm asking you to graph this line. That means to graph the set of solution of this equation right here. It's very easy to find a point solution. For example, I will take the point -3, 0, right? -2 times -3, 6, plus 0, 6. Okay, so -3, 0 is a point solution of the equation. It's right here. And then after that, I could find another point, or I can just play with the slope. -a over b is the slope. So that's what? That's negative. A is -2, b is 3. So it is 2/3. How do you play with the slope? Well, you know that this is the rise, and this is the run. Okay, 2, 3 is the same as -2 over -3. So let me show you. 2, 3. So the run is 3, so you move right 3 units, and the rise is 2, and up 2 units. Right 3, up 2. But now, what about if you look at, I made a mistake right here, I meant -2 over -3. What about if you look at this one, -2 over -3? -2 means you go down by 2. You go down by 2 right here, right? And here, let me add the arrows here. And -3 means you go left 3, all right? And these would be points on the line right here. I've used a slope to graph this line. Very simple. I'm going to let you number 6. I'm going to do example number 7. I want you to find the standard form of the line that goes through this point right here. Let's get the slope. What's the slope of this line? 5 minus 5. Oh, whoa, that's 0. And then -6 minus -1, -6 plus 1. So 0 over -5 equals 0. The slope of this line is 0, right? Let's take a point on the line. So I'll take a point xy right here, xy, and I will take the point -1, 5. And I'm going to say that the slope between these 2 points must be 0. How do you express that? 5 minus y over -1 minus x has to be equal to 0. When is a fraction equal to 0? When the numerator is 0. 5 minus y must be 0. Y equals 5. Okay? Now, of course, we're going to see later that we could have gotten this directly. The equation of a line with slope 0 is always of this form, and the graph is just a horizontal graph right here. Okay? Y equals 5. Okay, let's go over the last example, but before that, I need to define the x-intercept and the y-intercept. So given a linear equation in 2 variables and given its set of solution, which is a line, what do we call the x-intercept? This point right here, where the line crosses the x-axis. So this is the characteristic of this graph. What happens right here for the equation? Well, this is where y is equal to 0. So you said y equals 0 and you solve for x. What do we call the y-intercept? The point where the graph intersects the y-axis. So how would you find the y-intercept? Well, here the characteristic, the algebra characteristic is where x equals 0. So you said x equals 0 and you solve for y. Let's go now over the last example. So this one is going to be super easy. You want to find the y-intercept. You have to set x equal to 0. So if x is 0, what do you have? 3y equals 6, y equals 2. Now be careful. Something I didn't tell you, it's written in my note. The y-intercept is a point. Therefore, don't stop here. You need to write the coordinate of a point. The point is 0, 2. This is my y-intercept, okay? If you write y equals 2 or if you write 2, you're gonna lose some points right here because the y-intercept has to be a point. Let's get the x-intercept. How do you find the x-intercept? Well, you make y equal to 0. And what do you have? If y is 0, you're left with -2x equals 6. So x equals -3. And so your x-intercept is -3, 0. That's it. Please finish all of the other example, and thank you for watching.